So here's the thing that drives me crazy. It's answer because reason. Don't give me all these reasons up here and then just try to like just grab them a little bit. It's answer because reason. Hello everybody, this is Cranky Calculus here to go over an old test of mine. Yes, you heard it right, an old test of mine, and that way I can help you out. Do not forget to like and subscribe and ring that bell. I also am going to post this for free in the description. Did you get that? This is for free. The blank slate of this, it's free. So what you're going to do here is you're going to pause the video. You're not going to X out of the video. You're going to pause the video. You go ahead and print this thing out. You're going to work on this thing on your own, and you're going to come back to this video and obviously watch the entire thing because I'm sick of y'all just like clicking little bits and pieces here and there. I need you to watch the whole thing, all right? If you watch the whole thing, I'm more likely to do more of these videos. All right, I'm getting sick and tired of you freeloaders just watching a couple things, getting some stuff out of the way, and then moving on. I need you to watch the whole video. I need that algorithm cooking here. So make sure that you're watching the whole video. Make sure you're liking the video. If you want to see more videos like this, you better like this. If I don't get enough likes or my percentage of watching is not high enough, this might be the last video. So it's up to you. Do you want to see more videos where I'm working out old tests? It's up to you. For my class, I call this Unit 4. If you're doing this in any other class around the country, this is CED Unit number 5, which is going to cover anything to do with Extrema. Mean value theorem is covered in that as well, and anything with curve sketching in terms of, not the actual sketching itself, but the increasing, decreasing concavity, point of inflection, critical points, anything like that is covered in this video. So let's get rocking and rolling. So let's go ahead and look at this first problem here. Let's go ahead and read through it. So we're going to have two things here. We have a graph which is continuous function of g that is shown right there. That graph of g is only from -3 to 5, and g is twice differentiable except at x equals 1, probably because it might be a vertical tangent. It's not the perfect picture, but we'll deal with it. And we're going to let f be the function with, we know f of 1 is 3, and the derivative is going to be f prime is, you can see it right there. So we have everything that we need. We have g, we have f prime. Let's get rocking and rolling here. So find the x-coordinate of each critical point of f. Classify each critical point as a local, as the location of the relative minimum, relative maximum, or neither. So we just care about the x-coordinates. Let's go from there. So what's really nice is we already have the derivative. So all we need to do is just factor out an x from there. So I can rewrite f prime of x as, I can take an x out, so I'm going to get x times 6x minus 5 times e to the x. So I'm going to set this equal to 0 so I can find my critical points. Also, please take note that I also want to find where I'm undefined, but for this derivative, it's not in a ratio, so it's not going to be undefined anywhere. It's not any type of piecewise function. It's pretty straightforward. So there's no undefined parts here for f prime, but I'm going to take each one of these. I'm going to set x equal to 0. I'm going to set 6x minus 5 equal to 0, and I'm going to set e to the x equal to 0. Get my critical points from there. So I'm taking each individual factor and setting them equal to 0. So now for the first one, I have x equals 0. That's great. If I solve for x on this one right here, I'm going to get x equals 5/6. And right here, e to the x will never equal to 0. So I only have two critical points. So I'll CP critical points at x equals 0 and 5/6. So what I'm going to do is, there's two options. You can use the second derivative test, but that requires me to find the second derivative. I don't feel like doing that. I do know enough information to go ahead and use a sign chart. So the sign chart can't actually earn me points, but it can give me enough information to earn points. So I have critical point here at 0 and at 5/6. So I do my sign charts a little bit differently than maybe your teacher teaches it. I do them, to me, the easy way. So if I'm looking at each factor right here, e to the x is always positive, so I'm going to ignore it. There's no reason to consider it. E to the x is always positive. So my right end behavior, every value larger than 5/6 is going to be positive. My right end behavior is positive because I only have positive x's. So I'm going to go positive. And then at 5/6, that's going to be this factor right here that I'm underlining in purple. That 6x minus 5 has a power 1, which means it's going to go through the x-axis, which means that I change signs. Oh, I'll try to keep that the same color. I change signs. And that 0 that has a degree of 1, that's also going to change signs. So you can see I can make my little arrows right here. And because of that, I can identify each of these as a relative minimum, maximum, and so on and so forth. So I'm going to have a relative max at x equals 0 because f prime changes from positive to negative. Make sure you write it out as well. It's a good habit to get into. And then I'm going to have a relative min. And I only care about the x values, which is nice. I don't need to plug anything in. Relative min at x equals 5/6 because f prime changes from negative to positive. Just fit it on there. All right. Hopefully you found that pretty easy to do. So let's go ahead and move on to the next problem here. So now we're going to find all values of x at which f has a point of inflection. So now I have to take the derivative. I was hoping to escape that, but I'm going to go ahead and take the derivative of f prime. Just for the sake of ease, I'm going to rewrite what f prime is right here, just so that you can see this on the screen. So f prime of x is equal to 6x squared minus 5x, and this is e to the x. So I'm going to have some product rule here. So I'm going to have my first function in blue right there, my second function there in pink. So to find this second derivative, I'm going to take the derivative of the blue underline first, which is going to be 12x minus 5 e to the x. And then I'm going to take the same, I don't even know what I'm talking about anymore. I'm going to just leave the first the same there. And the derivative of e to the x is very good, everybody. It's e to the x. All right, and I'm going to set this equal to 0 to get my potential points of inflection. And this, I have a GCF of e to the x, so I'm going to take out an e to the x, and then it's going to leave me with 12x minus 5 plus 6x squared minus 5x. I think I can clean up that inside. Let me know if I'm wrong here in the comments. 6x squared plus 7x minus 5 equals 0. If I'm right, also let me know in the comments. Again, like seriously, we need to be more interactive on these videos, or these videos are going to go away. So this does factor, again, e to the x. Hopefully you know how to factor this. I'm going to just kind of do a little bit of guess and check here. 3x and 2x. There's tricks that people use to factor this. Don't use tricks, just like, know how to factor. 5 and 1 is the way I want to get this. I'm just going to guess and check here. 5 and 1, that's going to give me 3 and 10. Perfect. 3 and 10 will get me this as long as I add my 10, subtract that. So I'm going to get potential points of inflection at negative 5/3 and 1/2. Again, e to the x cannot equal 0, so I'm not worried about that. So when I put this on a sign chart, man, I really hate plugging in values. It's not my thing. I just try to find the behavior of the end behavior and find the behavior in between just by seeing when my critical points go through the x-axis or if they bounce off them or tangent to it, I guess is the more technical term. So for this right here, my right end behavior, since my x's are all positive, is going to be positive. And then at the 1/2 factor has a power of 1, so I'm going to change signs, and the negative 5/3 factor also change signs. So here I do have, and this wants x values, right? X values, we have a point of inflection, so we have points of inflection at x equals negative 5/3 and 1/2, because common error here. People are always like, it's because f double prime is equal to 0. No, it's not. It's because f double prime changes signs. Get that right, people. I'm sick of the mistakes I see all the time. That's why I'm making these videos. I'm sick of seeing mistakes. Let's stop making them. Let's understand this stuff and stop cramming all this stuff in there. All right, learn this stuff ahead of time. As you're doing this, if this is a video to study for a test, I'm hoping that you've already done your studying and you're already kind of sharp at this so you can kind of see where you're at. All right, so part C here, determine the intervals where G prime is negative on the interval from -3 to 5. Give reasons for your answer. So G of X is right here. It's going to be this graph right there. So now whenever I see, I'll come back there in a second, I see G prime is negative, that makes note that G has a negative rate of change, which means that G is decreasing. Okay, so where are the intervals where G prime is negative, which means when is G decreasing? I'm going to let you stare at this. We're going to stare at this together until we can figure it out. When is G decreasing? If you said on the entire interval, I'm going to agree with you. And the interval of this is only from -3 to 5. So we have here G prime, answer the question here, G prime is negative on -3 to 5. It's on the entire interval because, so here's the thing that drives me crazy. It's answer because reason. Don't give me all these reasons up here and then just try to just grab them a little bit. It's answer because reason. I already wrote the reasoning up there, but that to me was a little bit of side work. I want to actually justify this by tying it in. So G prime is negative because, and you have to talk about G. You don't have anything else. You only have G to talk about, so you have to talk about G because G is decreasing. All right. Part D, let H be the function. Oh, we have a new function H, which actually is the product of F and G. Is H increasing or decreasing? We're just going from 1 to 5. That's all we care about. This is from 1 to 5. So here's G up here from 1 to 5. And then we have F prime, obviously. So, so is H increasing or decreasing on the interval? So let's go ahead and find that derivative, actually, of H. So I can tell this is going to be a tricky one. I can tell. Not the derivative part of it, but all of the behind the scenes stuff. So H prime, behind the scenes, what am I talking about? This is F prime of X, G of X, plus F of X, G prime of X. Okay. So with that, let's do some investigating here. So we do know a couple things. We do know that I made a sign chart for F prime. F prime is always positive after 5/6. And you can see that right there. So I do know a couple of things here. That F prime, I'm going to write these off to the side. F prime is positive from 1 to 5. Okay. And if F prime is positive, that means F is positive. How do we know that? Let me get to it. Jeez, so impatient. If f of 1 is 3, which is positive, and we said that the derivative is positive, which means I'm increasing. So I'm starting at 3, at x equals 1, I'm at 3, and then my f prime is positive, which means that I'm going to remain positive here. So that's why f is positive, because the value at 1 is positive, and f prime is increasing the time, so that's going to be positive. G, I know everything about G. I have that picture right up here to show you. So clearly G is negative. Okay? So G is negative on 1 to 5. And let's talk about G prime. G prime is, it's decreasing the entire time, so G prime is negative. So G is negative because we're below the x-axis, and G is decreasing, so it's negative. So G prime is negative. Okay. So let's talk about this. So f prime is positive, G is negative, plus f is positive. So we've got that times that, plus f prime is positive times G prime is negative. So you're going to get a negative plus a negative, which is a negative. So H prime is always negative. on from, not always, but for the 1 to 5. So since h prime is negative, I can say that h is decreasing because, all right, I'll be more specific. Is decreasing on 1 to 5. H prime is negative on 1 to 5. All right, that was the FRQ part of this, and hopefully that was helpful for you. To our multiple choice questions here. Consider the function g of x equals 3 minus 2x minus x squared on this interval from negative 4 to 2. Which of the following statements must be true? So does g have an absolute maximum value on the interval? Does g have a relative minimum on the interval? Does g have an absolute, or sorry, g has no absolute minimum on the interval. So let's go ahead and see what's true here. I'm going to quickly sketch this. Do we agree that this is a down parabola and the endpoints are open? I don't even know what this thing looks like. Let's just say that. I don't know which one's higher, which one's lower, but it looks about that. Okay. With that perfectly accurate drawing, can we see which one's true here? 1, 2, and 3. So it says g has an absolute max value on the interval. I 100% agree with that, and that's going to occur somewhere right here. And that is true because we are a down parabola. It's nice to know what these things look like. G has a relative minimum on the interval. That's just not true, because you can tell from my drawing here, since my endpoints are open, actually doesn't mean anything. Relative minimum means that the derivative is going to change from negative to positive. That doesn't happen here. We have a down parabola. You can even check it by finding the derivative, which is negative 2 minus 2x. You can go ahead and take that derivative and run with it and see the critical points. Looks like we have a critical point at negative 1 here. And that's going to be our, since, by the way, I only have one extrema, it has to be absolute extrema. Or one extrema, so since it's a relative max, it's going to be the absolute max. G has no absolute min. Is that true? You bet it's true. Why is that true? Because the endpoints are open. There is no absolute minimum here because my endpoints are open. So 1 is true, 3 is true. Let's go ahead and circle D for the answer there. D for the win. Our next multiple choice question here we have, which of the following functions does not meet the conditions to apply the conclusion of MVT? So before we even apply the conclusion here, the conditions are, first off, 1, that we must be continuous, we being the function, on the interval from A to B, and we must be differentiable inside that interval A to B. Be careful. You can be you don't have to be differentiable on A or on B, just inside of it. Let's go ahead and look right here. So for A, we should know that A is going to be what that looks like. I mean, it's the ln of x function. All right, with an absolute value there. I'll underline this purple so you know what I'm talking about. That's continuous all the way through, and it has a derivative everywhere from 0 to infinity. So this applies. So since MVT applies, it's not an answer choice. I'm trying to see what does not meet the criteria. I know the answer, so I'm going to jump down to other things. I'm coming down here to B. I have, I don't know why there's a plus minus here. I feel like when I made this a PDF, it did a bad job. This should be a plus sign. I have no clue why there's a minus sign right there. That's why you gotta watch the video. You never know. Hey, we have a vertical asymptote at x equals negative 1. That means I'm not continuous at x equals negative 1. Not in the interval, not a big deal. Okay. And then it's not going to be differentiable. If you do the quotient rule, then you're only going to be not differentiable there at negative 1 as well. So this one right here, D, is good to go because I'm not in that interval there. I'm from 0 to 2. So if I do a quotient rule, I don't want to waste your time doing the quotient rule for this one. You can try it on your own. But you're only going to be not defined at x plus 1 squared in the denominator of the quotient rule. Everything in the numerator would be totally fine. So I'm actually good to go there. For C, I have no vertical asymptote. If I do the quotient rule, the same thing's going to happen that I just talked about D. Give me no bueno. Even if you're a little fuzzy on that, let's go ahead and look at this guy right here. This one, I hope you know what this looks like. This looks like a bird. You know how you draw birds back in first grade? It kind of looks like that. So it is continuous all the way through because, first off, you can plug in any x value and you're totally fine. But then the derivative of this, so y prime is going to be 2 over 3x to the 1/3, which means that x cannot equal 0. And since 0 is inside of that interval there, we're not differentiable at 0, so we cannot apply MVT because we're not differentiable everywhere inside of that interval. So the answer is going to be B. All right, here's a doozy for you. If we have f prime is x minus 1, x plus 4 cubed, find the value of c where f of c is a critical point and a point of inflection. So real quick, what are my critical points at? So if I set f prime of x equal to 0, that's going to happen at x equals 1 and negative 4. I can't write these days. At 1 and negative 4. Okay, it's very clear, just because it's already factored in factor form for me. So let's go ahead and find that second derivative. That purple. So let's go ahead and find that second derivative. So it's going to be product rule. So the derivative of the, again, I have the first right there, and then I guess I'll do red for the second. So I have purple and red. So the derivative of the purple is just 1. So I'm going to write down just the red part, which is x plus 4 cubed plus x minus 1. And the derivative of the red here, a little bit of chain rule, is going to be 3x plus 4 squared. I think that's it. Yeah, that's what I got. So now from here, set this equal to 0. All right, instead of expanding everything, and it's going to be a mess, why don't we find a GCF here? I found a GCF of x plus 4 squared. Okay, so the first term, I'm going to have just an x plus 4 left. And on the second term, I'm going to have 3x minus 1. Hopefully you're good at Algebra 2 because that's what you should be doing in Algebra 2. Should. I know not every district teaches quite like this. Not like mine. But we get this right here. And let's go ahead and distribute that 3 and fix that inside a bit here. So I'm going to get x plus 4. Squared is going to stay the same. I'm going to get 4x. Right, I have 4 x's in there. And then plus 1. Yeah, plus 1. Distribute that 3 all the way through there. And you'll get this result equals 0. So I'm going to get x to equal negative 4 and x to equal negative 1/4. So let's go ahead and make my sign chart. So negative 1/4 is right here. Negative 4 is right here. My right end behavior is positive because all my x's are positive. I do change signs there at the 4x plus 1 factor. Because it's got a degree of 1, so we change signs. And then at this negative 4 factor, we actually do not change signs. I'm going to stay the same there because of that squared. It actually is the graph, the second derivative is tangent to the x-axis. So because of that, I only have a point of inflection, POI, point of inflection, at x equals negative 1/4. So I have a critical point at 1, negative 4, and a point of inflection at negative 1/4. Is there a value where all of that we have a critical point and a point of inflection? No. So the answer is D. We are going to move on to the multiple choice questions where we can use the calculator. Before I finish up this last part of this, do not forget to like and subscribe. Okay, if you have not liked yet, not subscribed yet, what are you waiting for? Here we go, number 5 here. The derivative of the function of f is given by the f prime of x cubed minus 4 sine x squared plus 1 on the interval from negative 2.5 to 2.5, which of the following values does f have, or x, values of x, I can read, does f have relative maximum? So what we're going to do here is you're going to go to calculator. I'm going to go to Desmos just because it's easier to show on this. And I'm going to go ahead and type in my Desmos, just my f of x. I can't type in f prime of x, but I can type in f of x, and I can go from there. So, and this is all typed in right about now. Now, I only care about this between the values of 2.5, negative 2.5 and 2.5. So yeah, there are the values right there. I'll zoom out a little bit too. You can kind of see that it stops right there at 2.5 and negative 2.5. Now, if all I'm doing is just looking at relative extrema here, I'm looking at specifically relative max. This is the derivative. What I'm going to do here is I'm going to make a sign chart. When I make that sign chart, I know that I have 0. So f prime is equal to 0 at this negative 0.47. I have another 0 here at this 0.542 something, and I have a 0 right there. So I'm going to go back to my other sheet right here, and I'm going to make a sign chart of f. So f prime sign chart. Well, I really only care about from negative 2.5 to 2.5, but anyway, I have my first one here at, what did it say, negative 4 point something, negative 0.475, I believe it was. And then I have one here right here at 0.542. And then I have one right here at 1.396. I'm going to real quickly verify that. Those are all correct. Yeah, we're good. Okay, so on my sign chart here, left of the negative 0.42, I am negative, and then I am positive, and then I'm negative, and then I am positive. So as we can see here with the behavior, I'll do this behavior in blue. We're going down, then up, then down, then up. Clearly right here, I do have my relative max at 0.542. So be careful on these problems that we're already giving you the derivative. All you have to do is just find the sign chart for that and get the answer, which in this case is going to be E. This next one, we do have optimization coming up. And so how that one's going to work here is we have a particle that moves along a curve, y equals the square root of x plus 2. I'm going to draw that for you right here. It's just a square root function that got shifted left to. We're trying to find the minimum distance from the origin to the curve. So right there is the origin, trying to see what the shortest distance is. So real quick, the distance formula is d equals square root of x minus x1 squared plus y minus y1 squared. Make sure that square root covers everything. And what I'm going to do is I'm going to plug in information and rewrite this as a function of either x or y. Well, take a quick note here. The origin here is going to give us the distance from 0, 0 to the curve. So my x1, y1 are both going to be 0. So I'm going to write this as a function of x, which is the square root of x minus 0, squared plus y, which I know is root x plus 2, minus 0. And that's all squared. So now I can rewrite this as a function where we had x squared, and then that square root minus 0, which is going to be the square root, which gets squared, so I'm going to get plus x plus 2. So now I'm going to take the derivative of this. I want to find the minimum. I'm going to get, this is a little bit of chain rule here, I'm going to get 2x plus 1 all over 2 square root of x squared plus x. That should be a plus 1 up here. Little error. There we go. Oh, 2. It should be a 2. What am I doing? What are you thinking? I'll eventually get it right. Okay, so I'm here. So I want to find out when the critical points are. Just so you know, the denominator will never equal 0 because the denominator does represent the distance. So since the distance is never 0 on this problem, I'm going to ignore that part. But I do want to see what this does equal 0. You can clearly tell that d prime of x equals 0 at x equals negative 1/2. And you can kind of check this out too with the relative extrema. This is d prime, this is negative 1/2. You can clearly tell that this is sign chart is going to go minus then a plus, so this is going to give us a relative minimum. Since this is the only relative minimum, it must be the absolute minimum. So when I find this value out, I need to find in d of negative 1/2, which means I'm going to plug in to my equation here. So I'm going to do negative 1/2 squared minus 1/2 plus 2. When I do that, I'm going to spare you the ability to look at the calculator there, but you're going to get an answer of D. Our last question here, we have the graph of f prime, which is given to us. Super nice. Which of the following describes the extrema of f on the open interval? This is between a and b. Real quick, I'm going to just quickly, since those are a and b, I'm going to just go ahead and note some of these. This is going to be x sub 1, x sub 2, x sub 3. So I'm going to make a sign chart here from a to b. And this is of f prime. This one does not use a calculator at all, which is pretty typical for a calculator section to have a couple of questions that are not calculator, well, not needed at all. These are usually more of the understanding the math that's going on if there's no calculator needed. So you can see if this is the f prime. F prime between A and the first point is below the x-axis. That's negative. But between those 2 points, you go positive, negative, positive. So now I can look at this and then start to match from this sign chart which one matches. So this says 1 relative max and 2 relative mins. So you can see right here that I have a relative min here. I have a relative min here. And actually, I have a relative max right up here. So that is going to match A. Just real quickly, make sure I didn't mess up here. Let me look at B. 2 relative maxes, that's not true. C, 3 relative maxes, that's not true. D is 1 relative max, which matches, but then it says 3 relative min. That's not true. And then E is 3 relative maxima. And do not forget, we do not include A and B. We did in AP pre-calc because that's how they rewrote it. But for calculus, we don't even consider the endpoints, which isn't even an issue anyway because this is an open interval. So you can't have relative max on an open interval anyhow on the endpoints. So our answer here is going to be A. Hopefully you learned something from this video. Hopefully you watched the whole thing. And hopefully you like and subscribe so that I can continue to make more content like this.